Good evening, everyone. Welcome to COMP1531. My name is Hayden. You've probably seen me before if you've watched our pre-recorded lecture for the course, but if you haven't, I'd suggest you stop watching now and you go and watch that first. There's a handful of you that haven't. You can see the pre-recorded lecture here on the lectures page on WebCMS3. But if you have watched that, which I'm sure many of you have, then welcome to Monday evening from week one, T2. You are the first students that have ever studied Comp 1531 in T2. So not that that's very exciting at all, but we can make it exciting, I guess. Tonight we're going to be going through a few different parts of the lecture. We have a really quick introduction about the course that's kind of a bit more about the content. That'll only take 10 or 15 minutes. Then we've got two lectures tonight on Git. Git is a very important tool for the course and is kind of arguably one of the more fundamental parts of the course. I will be very transparent with you all though and tell you that we will probably run over time a little bit tonight and tomorrow night just in week one. So if you do have to head off at 8 p.m. exactly, head off and watch the rest of it later because the recording's here. It's on YouTube. You can just watch it any time. But just so everyone doesn't kind of get super excited to finish at 7:55, I'd say there's a semi-reasonable chance we just need another 15 or 20 minutes. But we'll see how we go. I don't want to be here late either. But week one, it has a lot of content to get through. So naturally there's just a few things. But you can watch things online later. It's really easy. So let's get into the first little lecture together. Week one, right here. Let me just make sure I got the comments on and that I can successfully reward people for commenting. Does the recording come out immediately after the stream? So you can watch the stream anytime on WebCMS3 just by going to the timetable page here. You can click on that. You can just watch it later. Though after the lecture, I do snip it up into pieces and upload it to YouTube, typically that evening. So if you kind of want to watch them in smaller pieces per lecture, then you'll be able to find it on the recordings page. If you are watching this lecture for the first time because your friend sent you a link or something like that, everything you want to know is sitting on WebCMS3. You can Google it, WebCMS3 UNSW. You can just log in there. It's like our alternative to Moodle. I'm aware there are some students who don't study computer science or haven't used this software before because of other software the courses use. It's the standard CMS that UNSW Computer Science uses, so it's nothing particularly fancy, but you can find it. Just WebCMS3, and all the information is here. If you just click around, it'll be very, very manageable for you. Now, welcome to the course. Quick little bit of introduction and a disclaimer as well. So this is in many senses a new course this term. This will be the 6th time I have taught this course, and it will be the 2nd time that it has been at least partially rewritten. We have modified the course substantially from previous offerings in that we've moved away from Python, the programming language you might have heard of, and move towards another programming language called JavaScript, which you might have heard of. Now, why this is important is that this is not a programming language course. Whilst we do know that you will learn a programming language, the course has very little to do with the programming language in the sense that it's not the main outcome we want to see. If you come out of this course and say, I learned a programming language, then we think we've kind of failed in many ways. I'm not going to get into it now because we don't have a lot of time. I'll chat about it later in the course, but the really short answer is that in the world of software engineering, which is what this course is about, JavaScript, which is a programming language, and its associated ecosystems are more appropriate for your learning. Because we cared not just about writing a little bit of code, but actually building, scalable, well-maintained systems that have, frameworks and libraries and 100 other little things. So basically what you'll find is that if you go and leave the university world and you go out into the big, bad, scary world and you go and join a software engineering project at a small, medium, or large size company, there's a very strong chance, there is the strongest chance that what you will be exposed to is what we will be exposing you to in this course. So that's the reason for the change. Now, the point of mentioning that is that because the course has been overhauled pretty substantially, we appreciate your patience in advance, because we have rewritten every lab, we've rewritten every lecture, we've rewritten every tutorial, we've had to rewrite big parts of the project, and because of that, naturally there'll be the occasional little hiccup, and we do our absolute best to make everything perfect for you. So, thank you in advance for that. Really important question to start the course off. Why are we here? This course is called The Fundamentals of Software Engineering, or Software Engineering Fundamentals is the actual name of the course. And what exactly does that mean? Why come to this course? I know you say, you sit there and you think, I'm here, Hayden, because I was told to come here. I don't have any other option. And whilst that is true, the reason that we kind of force you here, we as in, the university, is because we want you to go through a very important transition throughout this course. And that transition is that when you did COMP1511, or COMP1911 for a couple of you, your objective was to learn how to write, code, learn programming by writing code to solve problems. That's what you did in that course. Whereas what we're going to be trying to teach you how to do is to learn how to be a software engineer by architecting and building software in teams. And what that means is that we're not just thinking about a little isolated code problem in a .c file, but we're thinking about architecture, big projects, how a real how does Netflix actually write software and get it out? How do companies like Canva, Atlassian, Google, how do they actually function? And the purpose is to give you a taste of that. So it's not about being a programmer, it's about being an engineer. It's really taking that next step, which is very, very exciting. COMP1531 sends you in a very different direction to COMP1521. These aren't kind of sequential courses. COMP1511 is in C, which is a very kind of, mid to low level language. COMP1531 takes us to a much higher level, kind of simpler language. And then COMP1521 takes you deeper into the computer. So we're kind of going a little bit further up from the computer. It's not about, electronics and circuit boards and microprocessors. It's really about software and products and teams coming together, which is why I think it is the most exciting course at UNSW. Now, common question we get at the start of every course that we just like to cover: what is the difference between computer science and software engineering? Well, that's an excellent question. Now, when it comes to answering this generally, everywhere, computer science is essentially concerned with the science of computers. How do computers work? What makes them tick? What is logic? What are booleans, if statements? It's really just about, it's kind of a thing, like you could do computer science sitting down in a lab by yourself, just tinkering with computers, right? You think about a scientist in a lab coat. Computer science is the kind of analogous equivalent version of that for computing, whereas software engineering is where we focus on building the right software for the right people and making sure that it's maintainable over time as it grows and the people working on it grow. And in a lot of ways, it's the same thing we learn. You learn about this all the time when you hear about engineering, Scientists understand the world, and engineers take what scientists learn and know, and they apply it to create and solve problems, to solve problems and create solutions for real people out in the real world. So that's what software engineering is. We're not interested in, being too theoretical about computers or anything like that. It's like, we understand computers, or at least a little bit. Let's go and make people's lives better, and let's do so in a way that isn't an absolute mess. If you ever tried to do anything with people, it always devolves into chaos. So, how can we actually do this? How does a company like Google have like 50,000 engineers that are actually doing things and not breaking all the time? Like, how does software like Google not just break? These are kind of the questions at the core philosophically of what we're talking about. So here it's like, a genius sitting in the garage alone, writing code, and Instagram's developers working on the Instagram app. You might be equally engaging in some areas of computer science because you're writing code and you have to understand computers, but one of those people are probably working in a large team figuring out how to get their code to work with other people's code. You get the point. I've talked about this enough. At UNSW, though, there is a computer science degree and there is a software engineering degree. They are in many ways the same. I'm not going to get into the technicalities of it because a bunch of you know, and those that don't know, it probably doesn't matter. But what I will say is that don't mistake what I've just kind of babbled about as if, like, if you're a computer science program student, then you're going in this direction, and if you're a software engineering student, you're going in that direction, because at UNSW they are basically the same, and industry does not discriminate. So what that means is it really doesn't matter in many ways what one you are studying, you will come out the end the same. So please don't stress about that at all. Don't get that. Oh no, there you go. Do you need to be a software engineering student to be employed as a software engineer? No. And last couple of things. Formally, I've given you some kind of really friendly versions of software engineering. This is an IEEE definition, one of those big kind of, international bodies. Software engineering, the application of a systematic, disciplined, quantifiable approach. You can read it. That probably doesn't mean a lot to you, but that's what it is. And then the summary of it, in a really friendly way that really just describes what we're doing in this course, is that we want you to be able to extract and understand the problem you're trying to solve. So when we, rather than just being like, write some code, we want you to understand why you're writing that code. We want you to design and develop code that resists getting worse as it changes over time, because all software changes over time, because new people work on it, why you're, doing it changes, and we need to help you figure out how to write software that doesn't get worse over time. We want to help you make sure that your software is correct, that it's safe, that it doesn't break. Think about all the software engineers out there working on SpaceX rockets or Teslas or other cars or planes or anything like that. They need to make sure that their software works and that it verifiably works, that they're sure that it works. We want you to understand the purpose of software is to make it available for other people, right? Like, okay, you can write software on your laptop. Cool, that's super exciting, but how do you give that to someone? There's no point you writing software if it's just for you most of the time. And we want to help you work together with a group of people and have fun and be happy and all of those things, right? We want you to actually experience that connection. So being a software engineer is about realizing that even though you write code, and even though that's intended for machines to actually run on, it's important that you consider other humans who you interact with. The last point on what software engineering is just, I think, one last nugget about why it exists, back to kind of the start. We said software engineering is about making code resistant and all working well at scale, but the really simple element here is that without good software engineering, businesses waste money. And most of you here will end up working for a business. UNSW is a business, Google is a business, everything is a business, and a business's job is to not waste money in many aspects, right? Not-for-profit's the same thing. When you write bad software, companies, organizations, institutions lose a lot of money because you either screw people over, have to compensate people, you have to get more programmers fixing all the problems. So in a lot of ways, what we're really talking about here is how to help you write software that doesn't break over time, that you can give to people that doesn't break over time. Get along with your friends, the people you're working with, your colleagues, and make sure that you don't screw anything up. That's really it. So these are the main topics in the course. We've covered them. Everything we do in this course kind of falls into one of these buckets. You can actually see this on the lectures page. If you go to the lectures page, you'll see that all of our lectures in different weeks. The uni is a not-for-profit business, yes. Universities are very complicated institutions, but you can simplify a university as a not-for-profit business. These are all the different kind of topics here that we go through. You'll see them on the lectures page. A big part of the topics all fall around this pretty central idea of what we refer to as the software development lifecycle, and that's the idea that, and you probably might remember this from high school or something, they talk about, when you build a building, you got to figure out what you're going to do, and then you got to plan it and get the blueprints, then you got to build it, then you got to quality assure it, then you got to, open it, and then you got to maintain it. A lot of this course is really about applying those same fundamental engineering notions to software. And the only difference with software, because software is pretty similar to other types of engineering, the main difference with software is that in software, we do the same stuff, but really quickly. Kind of happens nearly, every day, every week, every month. It's not like building, the Crown Casino in Sydney or Westgate Bridge in Melbourne or wherever you are. It's actually like something that's happening very, very quickly and very rapidly all the time. You'll hear iterations or iterative design come up quite a lot. Now, I'm just going to really quickly rush through these topics so we can get onto the Git stuff, because these are like the main topics in the course, and a lot of them touch on this software development lifecycle. Requirements as a topic is focusing on understanding the problem we're trying to solve. When someone comes up to you and they say, hey, can you go and buy me a new chair? It's like the chair is a solution to a problem, and that problem is that they need somewhere to sit. Or is it? Maybe they're getting a chair to put their feet on. Maybe there's a better solution to that. These are the questions we want to ask. So it's not just about doing the thing, but understanding why we're doing the thing. We want to understand good software design. And many of you kind of know this, right? You can have the solution. You can have everything there. You can have a desk with all your pens and pencils on it and your paper and your laptop and stuff. But if it's not organized well, and if you haven't set yourself up for success, then you're going to basically trip over yourself soon. So software design, both in terms of how systems are thought about and also how you write code, is a really big part of what we're thinking about. Writing code, we're going to write a lot of code in JavaScript throughout the course. This is still a coding course at the end of the day. Correctness, which is about making sure that your software does what it should. How do they make sure that some software never fails? You think about it, right? There's software out there all the time that just absolutely never fails, particularly with critical systems. How do we kind of go about being certain? We can write tests and stuff, but how do we be even more certain? We have the topic of projects, project management, which is that, code again that you write might just live on your computer, but how do you make that, how do you give that to people? How do you work with other people on your code? If you've ever done a group, I don't know if 1511 does group projects anymore, but if you ever worked with someone else, it's quite chaotic. And then how do you get all your work finished and give it to someone? How do you give it to 1 billion people? How do companies like Netflix, like Disney Plus, like Google, like YouTube, how do they just make software available to absolutely everyone? How do we work together? That's kind of tied a little bit into the projects element, but it's not just the hard skills. It's how do you be nice to people? How do you resolve conflict? How do you plan together? And then lastly, there is the element of the internet. This is a big part of the course. Full stack web development. You might have heard this somewhere before. We don't do a lot of it, but we essentially give you a little bit of a taste of what it's like to write software for the internet. Because nearly everything you use is on the internet, right? Web CMS3, YouTube, Microsoft Teams. Nearly everything is running through a web browser these days. So we embrace that and we say, well, let's teach you through that lens. And Patrice, I hope your name's Patrice. I'm sorry if I pronounced it wrong. Patrice has a great question, which is like, what does full stack mean? Full stack essentially means that you have everything from what an end user uses. So like think about when you have a phone app, like your banking app, CommBank, Westpac, NAB, ANZ. You have what you see on your phone, that's code running on your phone, and then that goes all the way through to, CommBank or Westpac's servers somewhere, which has other layers to it. As opposed to just like some C code you wrote on your laptop, which is just like some code that runs like this. There's not layers to it. So when we talk about full stack, we're talking about systems that have many layers. Couple of quick admin questions. Fossey says, do we get an individual mark or is the mark totally dependent on the group? Your mark in this course is extremely dependent on your individual contributions. If you don't contribute, you will pretty much get no marks. And we've worked tirelessly for many terms to make sure that that happens. So we put a lot of effort into making sure that we look after you. Ebenezer, when are we going to find out who's in our team? In your tutorial this week. So if you go to your tutorial this week, you will discover that. Last thing, I mentioned this at the start, and I'd just like to reiterate it again. We thank you in advance for your patience. All new labs, all new tutorials, big changes to projects, nearly, massively modified lectures. And we've done it all because we like the idea of giving you the best educational opportunity we can. And therefore, we're going to have fun. Let's work together, and the term will be over before we know it. At the end of every lecture, there is a QR code that you can scan, and that will open up a feedback form. If you're sitting there on your laptop with the slides up, you can click on the link. If you're there watching this somewhere and you got your phone nearby, just pick up your phone and take a photo of it. It takes all of 3 seconds to just very quickly give feedback. We just use that to figure out what lectures stuck and what lectures didn't stick with people. And then the last question I'll answer before we wrap this one up is, will the final exam be in person? The answer is no. That is how UNSW has set things up. It is an online open book exam, and we will chat much more about that later. And a lot of this information is also in the course outline. So that pretty much wraps up our course overview.